Hi students, I am Vivek Vishal and today we are into the second lecture of RE-NEET crash course. Okay, so today I am going to take 1 hour or 1 hour 15 minute session and we are going to discuss the most of the major topics or concepts which is in 1D motion or motion in a straight line. Okay, so as you all know, we are starting RE-NEET crash course. Basic mathematics already I have done. So this is the second lecture. Okay, and this is all about motion in straight line, motion in 1D. Okay, so let's start. So motion in 1D. So what important concepts are there that you need to remember? That see, first you should understand the difference between displacement and distance. Correct? So as you all know, suppose I start from this point A and I go to point B. Further, I move to point C. This is 3 kilometer. This is 4 kilometer. So if someone asks what is the total distance covered, it means how much you have traveled throughout the journey. What total distance or total length you have traveled. So this is 3 plus 4. So distance here will be 3 plus 4, that is 7 units. But if someone asks what is the displacement, so displacement is the shortest distance between the initial point and final point. Means what you have to do, you have to mark the initial point, you have to mark the final point, and you have to draw a line joining these 2 points. This is your displacement. The length of this AC is your displacement. So this is 3, this is 4. Definitely you know this will be 5. So in this case, displacement is 5 units. Correct? So what you can see, the distance total is 7. However, the displacement is 5 units. Okay. If I take another example, like suppose there is a body which is moving in this circle. This body started from A and it moves to B. Okay, from A to B. Now someone asks what is the distance and what is the displacement. Suppose the radius of this circle is R. R is the radius of the circle. So A to B, what is the distance? So this distance will be this arc length from A to B. Arc length from A to B. Now, what I can do, I can divide this circle into 4 parts. How to know this arc length? So, 4 parts. Now see, if I see the entire length of the circle, what is the entire length of the circle? That is circumference. What is the circumference? Circumference formula for a circle. Circumference will be what? 2 pi r. This will be the circumference. Now you can see this circumference is made of, see, this is one part, this is second part, this is third part, and this is fourth part. So it is made of 4 parts. So 4 parts constitutes one circle whose length is 2 pi r. But we have to find this length of one part. So one part length will be just unitary method 2 pi r by 4. That is pi r by 2. This will be the distance in this case. Someone asks that what will the displacement? displacement. So again what I said, you mark the initial point, you mark the final point and join them like this. This will be the displacement. This dotted line is your displacement. Now how to calculate? See, you know that suppose this is O, center. AOB is a right angle triangle where AO is radius and OB is also radius. So if I want to calculate AB by Pythagoras theorem, I can calculate. So AB will be, AB displacement is AB, which is under root R square plus R square, means root 2R. 2R square, that is root 2R. So this will be the displacement in this case. So this difference between distance and displacement needs to be, like, you should understand what is the difference. Okay. So for displacement, always remember initial point, final point. You join these 2 points, that will be the displacement. Correct. So this is important. Okay. Now, displacement, remember this thing, displacement is always less than or equal to distance. Correct. Displacement will always be less than or equal to distance. How? Like for example, if I am going from A to B and this is 3 units, someone asks what is the distance, so you will say 3. Someone asks what is the displacement, again initial point, final point, again this displacement will also be 3. Means for A to B journey, our distance is 3, displacement is also 3. If the body comes back from B to A, means now I am focused upon A to B and B to A. This complete journey, A to B, B to A. If someone asks what is the distance, so how much you have traveled? 3 plus 3, that is 6 units. But what will the displacement? See, you started from this point only, initial position, and you ended here only. So there is no displacement, initial and final point of the same point. So displacement will be 0. So you can see in this case distance and displacement are same. However, in this case displacement is 0, which is less than distance, that is 6. So always remember, displacement will always be less than equal to distance. You can write like this also. If distance, this distance I bring here, so displacement by distance will be less than equal to 1. Correct. So this is the first concept that you need to understand. Next, speed versus velocity. You know, speed is a scalar quantity, velocity is a vector quantity. How we define speed? So speed is defined as distance that you have traveled divided by time, and velocity is defined as displacement, how much displacement is there divided by time. So you have to calculate the displacement here and then divide with by time. So this will be velocity, this will be speed. Correct. Now one concept comes, average speed. Average means 3-4 intervals will be given, more than one interval will be given, and they will ask what is the average speed. I will give the example. So just you write speed formula is distance by time. So here you write total distance by total time. Similarly, here if they ask average velocity, so here it will be total displacement by total time. Speed multiplied by time. What is the time? Distance by speed. You used to learn in like our childhood classes. Speed equals to distance by time and all. When to apply these formulas? Because some students say, sir, we have another formula for speed. B equals to u plus at. Where v is also speed. So u plus at. When to apply those formulas? S equals to ut plus half at square. And when to apply these formulas? So always remember, these formulas you are going to apply. These formula you are going to apply over the interval where there is no acceleration, where there is no acceleration, or acceleration is equals to 0, or acceleration is equals to 0. If in a particular interval there is no acceleration, then you can apply speed equals to distance by time. If there is acceleration, then we have different formulas, correct? So if acceleration is not there, then you can apply speed equals to distance by time. I'll take one example, this average speed and all. Average speed equals to total distance by total time. For example, there is a bus which travels from A to B with a speed of 30 meters per second. And again it travels from B to C with a speed of 40 meters per second. Correct? And suppose this AB, it's given, is equals to BC. It's given in the question. They are asking, find the average speed to the entire journey, A to C journey. What will the average speed? So we will apply the formula. Average speed, total distance by total time. Correct? Now total distance will be AB. Suppose I write X plus BC. So this will also be X. Why? Because it's given in the question. So total distance will be X plus X, that is 2X, divided by total time. Suppose A to B, it takes T1 time, and from B to C, it takes T2 time. So total time, I should write T1 plus T2. Now, focus on A to B. Focus on A to B journey. Just focus on A to B journey, because we have to calculate T1. Can I write time? Time equals to distance divided by speed. And why we can use this formula? Because over this interval A to B, there is no acceleration. In this A to B, there is no acceleration. So time equals to distance by speed. Distance is X, speed is 30. Similarly, B to C journey, if I focus on B to C journey, T2 if I write time, again distance, that is X, by speed, that is 40. So we got T1 and T2. Now substitute the values here. So 2x divided by t1 x by 30 plus t2 x by 40. So x, you take common here, 1 by 30 plus 1 by 40. Correct? This x and this x gets cancelled out. And you can calculate further. I'm not much interested here to do the calculator. We have to cover more parts right now. So this is the technique how to solve this average speed. This x and x got cancelled. Now you can solve this and get the answer. So this will be our answer, average speed. Some students, what they do, 30 plus 40 divided by 2, average. What they have learned, average 30 plus 40 by 2. No. If they ask average speed or average velocity, go with the formula. Average speed is total distance by total time, like here we did. So this is the concept of average speed. Correct? So this is very important. These kind of questions, they repeat a lot. Okay. Next we have equations. Like if we have, what if we have acceleration? What if acceleration is not 0? Acceleration is not 0. If acceleration is not 0 and acceleration is constant, then we can use, we have 3-4 equations. First, final velocity v equals to u plus at. Final velocity equals to initial velocity plus acceleration into time. Second, s equals to ut plus half at square. Third equation was v square minus u square equals to 2as. And fourth one, s nth, distance covered in nth second, equals to u plus a by 2 2n minus 1. Now, you all must be aware of all these formulas. So, if there is acceleration and acceleration is constant, we can write this. Achha, acceleration you must be knowing now. What is acceleration? Means if you are riding a bicycle, you are maintaining some speed 30 meter per second, and again you accelerated. Means your speed got increased from 30 to 40. Means if there is change in velocity. If there is change in velocity, we call it acceleration. Acceleration we define as, you remember these points, acceleration equals to dv by dt. dv by dt. This formula is very important. How much velocity is changing in how much time, rate of change of velocity. One more formula for acceleration is important. Acceleration equals to v into dv by dx. Some students miss this formula, but this formula is very important. v into dv by dx. Let's discuss one question regarding this formula. Okay. Suppose, for example, then we will come to these four. For example, velocity is given 2x cube plus 8x plus 4. Velocity is given as a function of position. X is position. They are asking, find the acceleration. What will the acceleration at x equals to 2? Means suppose, what is the scenario? That there is one object which is moving. Suppose it is traveling. For example, I am saying like this. Okay. This is just one example. So at different location, different acceleration it is having. Correct? Like you are riding a bike You are accelerating. At different location, you have different like acceleration, and different speed also. You can see different speed. They are asking what is the acceleration at x equals to 2. When suppose this is x equals to 1, this is x equals to 2. When the body is here, when the object, when your bike is here, what is the acceleration? So see, here t is not given, so you can't write acceleration equals to dv by dt. So use this formula, acceleration equals to v dv by dx. So let's first find dv by dx. So dv by dx, you differentiate. This will be 3 to the 6 x square plus this differentiate 8 constant. This is 4 is constant. Its differentiation will be 0. So dv by dx we are getting 6 x square plus 8. So acceleration will be v, that is 2x cube plus 8x plus 4. This is v. dv by dx 6x square plus 8. This is our acceleration. They are asking what will the acceleration at x equals to 2. Put 2. Substitute the value of 2 here. So 2 into 2 cube plus 8 into 2 plus 4. 6 into 2 square, that is 4 plus 8. This will be the answer. Again, I am not solving. Main funda is not to calculate but to understand more concepts in less time. Okay. So this will be the acceleration. This is how we are going to do. Acceleration equals to v into dv by dx. Okay. Now coming back to these 4 equations, v equals to u plus at, e square minus u square equals to 2as, s equals to ut plus half at square, and s nth equals to u plus a by 2 2n minus 1. Now there is confusion between two formulas, that is s equals to ut plus half at square and s nth equals to u plus a by 2 2n minus 1. Now what is the difference between these two, s and s nth? Suppose for example body is here at t equals to 0, at b at t equals to 1, at c at t equals to 2, at d at t equals to 3. A to B, suppose this is 2 units distance, suppose this is 5 units B to C, and C to D, suppose this is 1 unit distance, 2 meter, 5 meter, you can write meter also. Okay. Now if someone asks what is the total distance covered in 3 seconds, how much the body covers in 3 seconds, how much a distance? Distance covered in 3 seconds. What do you write? So body initially was here, at the end of 3rd second the body is here. Means total distance covered in 3 seconds will be from A to D, means 2 plus 5 plus 1, 5 to 7 plus 1, 8 meter. This is the distance covered in 3 seconds, 8 meter. So if such kind of questions comes, what is the total distance covered in 3 seconds? What is the distance covered in 3 seconds? We are going to use this formula. But if someone asks what is the distance covered by the body in 3rd second, 3rd second. So 3rd second, what is the meaning of 3rd second? 3rd second means from at the end of 2 seconds you have to focus, and at the end of 3 seconds you have to focus. Like from here to here this is 1st second, from here to here this is the 2nd second, and here this is the 3rd second. So 3rd second means how much distance we have covered, this C to D distance, this is the 3rd second. Means when 3rd second began and when third second ended. So this CD distance or this 1 meter is called the distance covered in third second. Correct? When you have to find this third second, then we are going to use this formula, distance covered in third second. So again I am saying distance covered in third second means how much distance we have covered in the third second. Means at the end of 2 seconds, you have to start focusing on here at the end of 2 seconds, and at the end of 3 seconds, where you were, you have to focus. So this distance is the distance covered in third second. Now can I write CD as this total distance minus, means this total distance, that is AD, minus this distance AC? Can I write? AD minus AC will be what? CD. What is AD? It is the total distance covered in 3 seconds. AD, from A to D, total distance covered in 3 seconds. Minus AC. What is AC? What is the total distance covered in 2 seconds? Total distance covered in 2 seconds. At the end of 2 seconds, body is here. So this is AC. So distance covered in 2 seconds. Means what we can write, distance covered in nth second. We have got another formula. Is the distance covered in n second, the distance covered in third second, similarly distance covered in nth second. Is total distance covered in 3 seconds, total distance covered in n second, minus distance covered in 2 seconds. So we can write distance covered in n minus 1 seconds. Okay. So we have got another formula. Distance covered in nth second is equals to total distance covered in n second minus total distance covered in n minus 1 second. Okay. So always remember that you can write this formula according to the question. You see the question, you can use this formula also, distance covered in nth second, and you can use this formula also, distance covered in nth second. Okay. So this is the basic difference between total distance covered in n second and total distance covered in nth. N and nth is different. If they ask total distance covered in 2 seconds, you will use ut s equals to ut plus half at square. But if they ask what is the total distance covered in second, so you will write u plus a by 2 2n minus 1. Like for example, I will give that if you are dropping one object, you are releasing one object, one ball. They are asking what is the distance covered in 3 seconds. So you will use ut plus half at square. Initial velocity you know 0, so it will be half. Acceleration due to gravity, that is 10. Time in 3 seconds they are asking, 3 square, that is 9. So this will be 90 by 2, that is 45 meter. Okay. But if they ask what is the distance covered in third second, so you will use u plus a by 2 2n minus 1. U plus a by 2 2n minus 1. So initial velocity is 0. Acceleration is 10 by 2. 2 into n. Means at which second they are asking? They are asking at third second. So n value will be 3 minus 1. So 2 3 is 6 minus 1 5. 10 5 is 50 by 2. This will be 25 meter. See, distance covered in 3 seconds, it is coming some different. Distance covered in third second is different. Correct? So you need to understand this. Achha, someone asked what is the total distance covered in 2 seconds? 2 seconds. Total distance. So again, ut plus half at square. Ut will be 0. So half acceleration, that is 10. T square. 2 square will be 4. So 40 by 2 is 20. Now one thing you can see, the distance covered in third second is distance covered in 3 seconds minus distance covered in just previous 3 minus 1, that is 2 seconds. You can see distance covered in 3 seconds is how much? 45 minus distance covered in 2 seconds is how much? 20. So 45 minus 20 is 25 meter, which is the distance covered in third second. 25 meter. See. So this needs to be clear. Okay. Okay. See. Some important concepts you understand. Like some students are confused about where you should take positive, which side you have to take negative, right side positive, left side negative, what to do. Because when we are applying this equation, v equals to u plus at, s equals to ut plus half at square, v square minus u square equals 2as, you have to be very careful regarding the plus and minus sign. Now, how to decide? So always remember, select direction of motion. Select direction of motion or see the direction of motion. So whatever is in the direction of motion, you take everything positive. In the direction of motion, you take everything positive. And opposite, whatever is opposite to the direction of motion, okay, I will explain through one example. For example, like this is the ground and there is a ball. You are projecting up with a speed u. You are projecting up with a speed u. It goes till the maximum height. It stops for a moment here. This is the maximum height. It stops. They are asking how much time it takes to go up. Time taken to go up, or we call this time of ascent. Time taken to go up. Now how to solve? First, how to think? First, whether can we use time equals to distance by speed here? The time equals to distance by speed? No. Why? Why no? Because here we know that if you are throwing any ball, there is interference of acceleration. Acceleration is there in this scene. So I told you, time equals to distance by speed, you can't apply where there is acceleration. Here there is acceleration. So you have to focus on these 3-4 equations. V equals to u plus at, s equals to ut plus half at square, like this. Now, which equation to you need to choose? Some students ask. So they are asking about the time. So any equation you choose where time is there. Like for example, if I choose first equation, that is v equals to u plus at. Okay. Now you determine which direction and which side will be positive and which side will be negative. What I told, like if you are throwing the ball up like this, so direction of motion is up now. So in this direction, in the upside, we will take everything positive, and downside we will take everything negative. So final velocity, here this is the final velocity. Here the ball stops for a moment, final velocity becomes 0. Initial velocity u, now plus u or minus u, u is in the direction of motion, so plus u, plus acceleration, acceleration due to gravity. Now gravity always acts downward, so direction of motion is up, but acceleration due to gravity is down. It is opposite to the direction of motion. Direction of motion is up, gravity is down, so we will take minus t. Minus t. Now we will shift this, so gt will become u. So finally time will become u by g. So time to go up or time of ascent will be u by g. Correct? So this way, like we have to calculate. Like suppose another example I give, that there is a ball and this is the ground. You are releasing from a height h. From h height, you are releasing a ball like this. Correct? Then at what time it reaches down? Time to come down. Time taken by the ball to come down. Now again, if you use v equals to u plus at, so problem is final velocity we don't know, because any equation we have to take where time is involved. So if I take v equals to u plus at, problem is, see, time we don't know, this velocity we also don't know, final velocity with which the ball hits. Correct? Now if I use this equation, s equals to ut plus half at square, here also time is involved. Let's see. So if you are releasing the ball, so ball is going in downward direction. So this is the direction of motion. This is the direction of motion. Direction of motion is this. So along downward direction, everything we will take positive, and opposite to that, everything we will take negative. So what is the displacement of the ball? How much distance it is traveling? H. So h we should write plus h or minus h. Ball is going down now, so displacement is like this. So we should take plus h. Initial velocity, as we are releasing the ball, initial velocity will be 0. Half. Here what will be acceleration? The direction of motion is also down. Gravity is also down. Both are in the same direction. Means gravity, this acceleration is in the direction of motion. And what I told, in the direction of motion, take everything positive. So this will be gt square. So from here, this will be 2h, g will come down, 2h by g equals to t square. Finally, time will be under root 2h by g. This is the time that the body will take to come down. Correct? So these things should be clear. Okay. So direction of motion should be clear. Correct? Now some important points that you need to remember. If you throw any ball like this with some speed u, it will go to the top. This is the topmost point. The time that it will take to go up is called time of ascent, and we saw the formula is u by g. Now, always remember, if you are throwing any ball, suppose it takes 2 seconds to go up. Always remember, I am not deriving. Again, 2 seconds it will take to come down. If it is taking 2 seconds to go up, it will take 2 seconds to come down. So, come down means time of descent. Means from, suppose this is A, this is B. So, time of ascent will be time taken from A to B. Time of descent will be time taken from B to A. So, time of descent will be same. If it takes 2 seconds to go up, 2 seconds it will take to come down, u by g. So, they ask what is the total time the ball was in the air. So, total time is called time of flight. Time of flight. This is the total time. That is time of ascent plus time of descent. So, this will be u by g plus u by g, 2u by g. So, capital T or time of flight is 2u by g. Correct? Then they ask what is the maximum height reached by the object? H max. You can calculate also H max. Okay. You can calculate, see, using this formula. V square minus U square equals to 2AS. Like if I focus on A to B journey, my focus is on from A to B journey. A to B journey. What is the final velocity? 0 minus initial speed U. So U square. Acceleration. Direction is up. Acceleration is down. So minus G. And distance, that is H max. Correct? So minus minus cancel. 2G will go down. So H max is U square by 2G. This also you need to remember. H max formula, maximum height reached by the ball, U square by 2G. U square 2G will come. So H max will be U square by 2G. So this thing you have to remember: time of ascent, time of descent, total time of flight, maximum height, U square by 2G. Correct? One more thing is very important. At the same level, speed of the object will be same. Again I am saying, same level, same speed, same level, same speed. What does that mean? It means that suppose you throw the ball up with 40 meter per second. It will go up, its speed will decrease 30. Suppose here its speed is 30 meter per second. Like I will draw like this. Suppose at this point 30, at this point 20. And finally here speed becomes 0. Same level, same speed. What does this mean? When the ball will return, so suppose the ball is returning like this. Suppose the ball is returning. This is the return journey. Okay. It will return here only, but I am just to make you understand, I am playing. So the ball is returning. So at this level, at the time of return, here also speed will be 20 only. Here speed will be 30 only. So same level, these 2 points are at the same level, same speed, same level, same speed. Means when the ball will hit the ground, with what speed it is going to hit? With 40. The ball on the ground, I projected the ball up with 40 meter per second. It will return and hit the ground with the same speed, that is 40 meter per second. This is very important. Correct? So this point is very important. Okay. Suppose for example, one question I will take, that there is a building and you are playing on the terrace of the building with a ball. You projected the ball with 40 meter per second. You projected the ball up with 40 meter per second. The ball went up and it came down like this and it hits the ground. The ball hits the ground after 10 seconds. Ball hits after 10 seconds. They are asking, what is the height of building? What is the height of the building? Hope this question is clear. So there is a building, you are playing on the terrace, you are projecting the ball up with 40 meter per second. What will happen? It will go up to the maximum height. Then it will come down. It came down, 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 down like this, and it hits the ground after 10 seconds. They are asking height of the building. So see what to do in these kind of questions. See, we have a lot of methods to solve this. I'll just tell you one of the method. To tell me that ball will go like this, it will return here at this point. What will the speed of the ball at the same level? It is going up, then it will return. Same level, what I told, same speed. Means at this point, speed of the ball will be how much? 40 meter per second. Same level, same speed. So at this level, when the ball reaches this, the speed of the ball will be 40 meter per second. So see, okay. So from A to B and B to C, from A to B and B to C, how much time the ball must have taken? It is just like that, no? That you are throwing any ball, it is going up and it is coming to the same level. How much time? Time of flight. Time of flight, that is 2u by g. What was the u speed here? 40. So this will be 2 into 40 by g, that is 10. So 10 4 ja 40, 4 2 ja 8, that is 8 second. 8 second means the ball is going from A to B and back from B to C in how much time? 8 second. But it's given in the question, the ball hits the ground after 10 seconds. Hits the ground means from C to D, that is ground, from C to D. From C to D, if I focus on C to D journey, how much time the ball must have taken? 2 seconds. 8 seconds here and 2 seconds here, total 10 seconds. C to D, what is the initial speed? If I focus on C to D journey, what is the initial speed? 40. Can I write this distance h, CD or CD, whatever? CD is the height of the building, na? So can I write this distance s equals to ut plus half at square? Can I solve by this formula? What is the distance? That is the height of the building, h. What is the initial speed? 40. And I will take plus 40 or minus 40? Plus 40. Why? Direction of motion is down only. Speed is also down. So 40. Time how much? From C to D, 2 seconds. Plus half. Acceleration you know, 10. Acceleration due to gravity. And direction of motion is down. Gravity is also down. So plus 10. T square. Time is 2. 2 square, that is 4. This will be the answer. Height of the building. Okay. So this is a very good example to practice also. Direction of motion, how we are taking plus and minus, and also same level, same speed. Here we utilize this formula also, time of flight. This time taken from A to B, B to C, like this, 2u by g. Okay. So you can practice this kind of questions. Clear? Okay. Suppose there is a ball. At any height, suppose at this height, means from the top, the ball goes down, how much distance? H distance. They are asking what is the speed here. Can we use v square minus u square equals to 2as? So v means final speed, v square minus initial speed 0 equals to 2, acceleration g, distance is how much? H. How much distance? H. So v square equals to 2gh. So v equals to under root 2gh. So always remember, if you are releasing one ball and it is going h distance, then if they ask what is the velocity at that point, what is the speed at that point, under root 2gh. Means you can think like this also. If there is a ball and this height is h, if they ask with what speed the ball will hit, so from this level, how much distance the ball has gone? H. So what speed you will write? Under root 2gh. So this formula is also important. And I gave one more formula. How much time it will take to come down? Time to come down under root 2h by g. Under root 2h by g. If you are releasing any ball, what is the time taken by the ball to come down? Under root 2h by g. See here. Under root 2h by g. If you are releasing any ball, how much time it takes to come down? Under root 2h by g. So these are the important formulas that you need to remember. These things we have that I have kept in a box, those formulas definitely you need to remember. Next, see what I am saying. Velocity, what you can write? Dx by dt. Dx by dt. Means suppose if x equals to t square plus 4t, they are asking at t equals to 2 seconds, what is the velocity? So velocity you will write dx by dt, differentiate. So dx by dt will be 2t plus 4. I have differentiated this, t square differentiation 2t plus 4t differentiation 4. They are asking the velocity at time equals to 2. So put 2 into 2 plus 4. So 4 plus 4, 8 meter per second. You can solve like this. So first kind of question they can make like this. This is the first type of question. Second type, what we can write? See, suppose this is x. X means distance or position versus time graph. What will the slope of the graph? What will the slope of x versus t graph? What is the general formula for slope? dy by dx. In basic maths I told. So in place of y we have x. So we will write, see, basic formula is dy by dx. Here in place of y we have x. And in place of x we have t. So dx by dt. And what is dx by dt? Velocity. Means what we can write, slope is equals to velocity. Slope of x versus t graph gives velocity. Where x is what? Displacement. Where x is what? Displacement, t is what? Time. So this you need to remember. They can give like this, that there is one object whose x versus t graph is like this. This is x versus t graph of object A. This is x versus t graph of object B. Which object is having more velocity? So velocity is nothing but slope of x versus t graph. You can see here slope of B is more. So slope of B is more means velocity of B is more than velocity of A. Correct? Second kind, what kind of question they can ask? See, if we write v equals to dx by dt, Can I cross multiply and can I write dx equals to v dt? Cross multiply. Can I write, if I put integration both the sides, so integration of dx equals to integration of v dt. Correct. Integration of dx equals to integration of v dt. So suppose from x initial to x final and time t initial to time final, if I am writing time final, so dx integration, you know, dx integration is x. So x is final position minus initial position equals to integration of v dt, t initial to t final. This formula is very important. Now, when you are remembering, when I am writing any formula, now you should remember what are these things like x final position, I initial position of the object, where the object was finally, where the object was initially. Now, xf minus xy, this term we can write displacement also, displacement of the object, final position minus initial position, displacement. So, displacement is nothing but integration of v dt. Integration of v dt. Acha, you tell me, I told in basics that if we have v versus t axis like this, there is a graph like this. So if I ask what is the area under the graph, area, this area, what is the area under the graph? Area under the graph, integration of y dx. So if we have v versus t, what do we write? Integration of, in y axis it's v, in x axis we have t, so integration of v dt. V dt. Correct. Now area is integration of v dt. What is integration of v dt? Displacement. What is integration of v dt? See here, displacement. Means we can write, very important, displacement or final position minus initial position equals to integration of v dt equals to area under vt curve, area under vt graph. Correct. Clear? Now they can give questions like this, that velocity is t square plus 2t. What is the displacement from t equals to 0 to t equals to 2 seconds? Displacement they are asking. So displacement you can write, displacement will be integration of v dt. So integration of v, what is velocity? T square plus 2t dt. From where to where? From time 0 to time 2. And in basic mathematics I have told how to solve this. You can do t square dt, integration of t square dt plus integration of 2t dt. What you will get? I am doing also t cube by 3 plus this will be 2 outside, t integration will be t square by 2. So this gone, this gone. So finally t cube by 3 plus t square. This is your answer, and you have to put the limits from 0 to 2. From 0 to 2. You put upper limit, then minus lower limit, and this will be the answer. Again, I am not doing the calculation. Upper limit minus lower limit. Okay. They can ask like this also, that see, this is velocity, This is velocity and this is time. They will give the graph like this, that this is the graph. They will ask find displacement from t equals to 0 to t equals to 4 seconds. Now displacement, we know what displacement? Integration of v dt or area under vt graph. So this is vt graph. So you find the area under the vt graph, means this area. Now this you can calculate now. This is what? Triangle. So this area will be half base that is 4 into height that is 10, that is 20, and area under VT graph is displacement. If they ask what is the displacement, this will be 20 units. Correct? Similarly, what we can write? One more concept. We have one more concept. See. We'll see here. Acceleration. What is acceleration? dv by dt. So if we have v versus t graph, this is v, this is t. If I say one of the graph is like this is a, this is the graph of particle a, this is the graph of particle b. Now if I ask what is the slope of v versus t graph, slope general formula is what? dy by dx. So here it will be, in place of y we have v, in place of x we have t, dv by dt. So this is nothing but acceleration. So slope is nothing but acceleration. So they will ask whose acceleration is more. We can see the object B has acceleration more, slope more. So we can write acceleration of B is greater than acceleration of object A. Means slope of V versus T graph, VT graph gives what? Tells about acceleration. Acceleration means slope is nothing but acceleration. Means if they ask you to calculate the acceleration, you have to calculate the slope. Correct? Now similarly again, like velocity equals to dx by dt. If we cross multiply, same things will happen. See here, like what I am saying, acceleration equals to dv by dt. You cross multiply, so dv equals to a dt. You integrate both sides, so integration of dv equals to integration of a dt. Integration of dv will be v from v initial to v final equals to integration of a dt from time initial to time final. Now upper limit minus lower limit will become final velocity minus initial velocity equals to integration of a dt from t1 or to t2 or t final. Now again, if we have a versus t graph, acceleration versus time graph. If someone asks, suppose this is the graph. If someone asks what is the area under this graph, what is the area under this graph? So area you will write, area general formula is integration of y dx. So here area you will write integration of, in place of y we have a, in place of x we have t. So integration of a dt. But what is integration of a dt? Change in velocity. So change in velocity. See, integration of a dt is area under the graph. Area under which graph? Area under AT graph. Area under AT graph. So if you will calculate the area under AT graph, it will give you change in velocity. This point is also very important. If you calculate the area under AT graph, if you calculate this area, this will give you change in velocity. So if they ask what is the change in velocity, you can either do area under AT graph or integration of ADT. Just like similar to like v equals to dx by dt. Correct? So just one question I will take so that you understand again. That it's given that initial velocity is 2 meter per second. There is one object whose initial velocity is 2 meter per second. And they have given one graph. This is the graph. AT graph. Acceleration versus time graph. This is 12. This is 6. This is 8. They are asking, they have given initial velocity, means at t equals to 6 seconds. At t equals to 6 seconds, the initial velocity was 2 meter per second. They are asking, what is the final velocity? That is at t equals to 8 seconds. So what we know, that change in velocity, final velocity minus initial velocity, is equals to integration of a dt, and integration of a dt is nothing but area under AT graph. This is the AT graph, means this area we have to calculate. Now this is 6, this is 8, so this will be 2 multiplied by, you can see this is a rectangle, this length is 12. So 12 to the 24. So final velocity they are asking, final velocity minus initial velocity we are getting 24. So final velocity will be 24, this minus v initial will go there, plus v initial. So 24 plus initial velocity they have given 2, so it will be 26 meter per second. So this kind of question can also come. Clear? Hope this is clear. One more last concept that I want to tell. That is the concept of relative velocity. See here. Suppose there is a train which is traveling in this direction. This is train A. The speed of train A is 100 meter per second. And there is another train B which is also traveling with the same speed, 100 meter per second. Means there is one train which is traveling this path with 100 meter per second. There is another train here which is traveling this path with 100 meter per second. Suppose I am on the window side of this train. There is another person on the window side of that train. So both of us can talk with each other. Why? because this train and my train has also like both of the train have the same speed. So we can talk because no one is going away. They are maintaining the same speed. So what I will feel that this person is at rest because this is not moving now. Actually, both of us are moving with same speed. But all the time, means if I am coming forward, that person is also coming forward because we have the same speed. So we will feel that we are at rest with respect to each other. So if I say, what is the velocity of A with respect to B? Velocity of A with respect to B. How we write? First you should know to write. We write like this, velocity of A with respect to B. This is how we write. Slash velocity of A with respect to B. So velocity of A with respect to B will be velocity of A minus velocity of B. Now some students, 100 minus 100, 0. See, velocity is a vector quantity. You have to take care of direction. Okay. I have always told that suppose this direction, each direction, you take I cap. This direction will be minus I cap. This direction we represent by j cap. Downward direction will be minus j cap. The direction which is coming out of the plane of the board is k cap, and going into the plane of the board is minus k cap. Now since velocity is a vector quantity, you have to take care of the direction also. Like if I write VA minus VB, so velocity, what is the magnitude? Magnitude of the velocity is 100. And this train A was moving in which direction? This direction, each direction. So 100 I cap minus velocity of B. B was also moving with 100 meter per second and direction I cap. So 100 I cap, 100 I minus 100 I 0 means velocity of A with respect to B, means with respect to B, from B point of view, velocity of A will be 0. And I told her, yes. Similarly, velocity of B with respect to A will also be 0. Both respect, the velocity will be 0. Correct. So this is how we calculate velocity of any object with respect to another object. This formula you should remember. Velocity of A with respect to B, VA minus VB. Now, see. Suppose train A is coming with going in this direction. Speed of train A is 100 meter per second, and train B is coming from this direction. Train B is coming from this opposite direction. The speed of train B is also 100 meter per second. Now what? When they cross each other, what A will feel about the velocity of B? What A will feel about the velocity of B? Means I want to know velocity of B with respect to A. It means what A will feel about B. So what we will write? We will write velocity of B minus velocity of A. This is the formula. B with respect to A, VB minus VA. With velocity of A with respect to B, if someone asks what is velocity of A with respect to B, so VA minus VB. Now velocity of B, value is 100 meter per second and direction is minus I cap. So I will write like this. This is velocity of B minus velocity of A. What is the velocity of A? Value is 100 and direction is I cap. Now minus 100 minus 100, it becomes minus 200 I cap. So see, velocity of B with respect to A is minus 200 I cap, means A will feel a velocity of 200 meter per second about B. Means if I am A, for me, this B train is moving with 200 meter per second. And you must have felt that. If you are traveling in one train, another train is traveling from another direction. So when it comes at your position, you will feel that this train, the other train is traveling with lot of speed. Correct? See, speed has increased. 100, it doubled. So velocity of B means another train with respect to this train is 200 and minus I cap means this A will feel that A was going in this direction, A will feel that B is going in the opposite direction. And definitely B is going in the opposite direction. Correct? Now there is like one example I will take. Suppose A is traveling in this direction. Speed of A is 3 meter per second. And there is another object B which is traveling in this direction with 4 meter per second. This is the speed of B. Now if I ask that what is the velocity of A with respect to B, this if I ask, what you will do? You will write VA minus VB. Basic formula. Velocity of A 3 J cap. Don't forget to write I cap J cap. Minus velocity of B 4, and in this direction means minus I cap, means minus 4 I cap. This is the velocity of B. So 3 J cap minus minus plus plus 4 I cap. This is the velocity of A with respect to B. If someone asks the magnitude of any vector, you can calculate under root 3 square plus 4 square, that is 5. Okay, but this is the velocity of A with respect to B. Correct? Now this relative velocity approach can also be solved by another method. Last 5 minutes I am taking. Just see. This is the last 5 minutes. And I will end the class. See. Suppose what I am saying, there is train A which is moving with 100 meter per second. Its acceleration is 2 meter per second square. This is the acceleration of train A. There is another train B which is moving this side. The speed of train B is 50 meter per second. And the acceleration of the train B is accelerating with 1 meter per second square, or 4 meter per second square. And distance between these two trains, this distance between these two trains is suppose 1000 meter. So this train is moving in this direction, this train is moving in this direction. When these two trains will meet each other, when these two trains will meet each other at what time? Okay. So see, whenever this kind of situation comes, when two object velocity is given, that one object is moving, another object is also moving, you have to think about relative velocity concept. Correct? Now relative velocity, one way is to solve like how we solved velocity of A with respect to B, VA minus VB. One good method I am going to tell you what you have to do, because it is very difficult to analyze two objects moving with different speed. This is also moving, this is also moving. So what you do now, you stop one of the object. This is the method. This is a method how to solve this kind of questions, so that your headache is released little bit. What you do? You stop one of the object. So this object, suppose I stop here. Okay. This object I stop. So now this object train B is at rest. Actually in the question it is not at rest. Actually both the trains are moving. See the method how to solve. You make one of the object at rest. So this train is at rest now. Now give a I will just explain. See what I have done. This train B I have kept at rest. This train A was moving with speed 100. What was the speed of train B? 50 meter per second. Train B will give its speed to A. Train B, again you like listen carefully, will give its speed to A. Means it will donate 50 meter per second to A. But in the opposite direction. Opposite direction means train B was moving in this left direction. It will give to A in right direction. So now what will the speed of A will become? Its own speed was 100. It gets speed of 50 from B. So total speed will be 150 meter per second. 150. Correct? Speed of A. What will the acceleration of A similarly? Again, what I am saying, B will give its acceleration to A. What was the acceleration of B? 4. It will give its acceleration to A. But in opposite direction. Acceleration of B was here. So it will give in this direction, right direction. So actually, train A was having acceleration 2 in this direction. Now it gets 4. So net acceleration of A will become 4 plus 2, 6 meter per second square. Understood? So this is the concept what to do. You keep one of the object at rest, give its velocity and acceleration to the other object but in opposite direction. If it is traveling in this direction, give it in this direction. Correct? Now this question is like little bit simple. Why? See, they were asking the time. They were asking the time when they will meet. Acha, this train A will meet train B when it travels, because B we have made it at rest. When it travels this distance, when A will travel this distance and reach here, this A and B will meet. Means how much distance it has to travel? 1000. So can I use this equation? S equals to ut plus half at square. How much distance it has to travel? 1000. What is the speed of train A? 150. Means combined with that speed 150. Time plus half. What is the acceleration of train A? 6 t square. Now this is a quadratic equation. Solving this, you will get the time. Solving this, you will definitely get the time. Quadratic equation. Correct. So this is the time when A meets B. That was asked in the question. At what time A will meet B? Time. Question was, you can write the question also. At what time A meets B? Okay. So this will give you the solution of this question. Okay. So this was all about 1D motion. Okay. And next I will upload the lecture of unit and dimension. So what you people do, you revise all these concepts. If possible, try to solve like lot of questions, PYQs or whatever you have, and then again move to the next chapter. Okay. So tomorrow we will be doing units and dimension, and again you go through these lectures, this basic maths, this 1D motion, then unit dimension. So in in 1 month or 30 days or 25 days, we are going to complete major of the portions of this class 11th and 12th. Okay, stay tuned. Thank you. Thanks.